Standard AI models rely on probabilistic generation. They predict the next likely word, allowing language and ideas to multiply outward in a fluent, chaotic web. Their primary function is predicting statistical likelihood, not calculating truth. This linguistic fluency creates a false sense of security for human operators. When an enterprise team reads a beautifully structured paragraph, they assume a rigorous reasoning process produced it. The reality is that the actual reasoning is hidden. It is black-boxed deep inside the statistical weights of the model, making the logic inaccessible to the user. Because this reasoning is hidden, the AI cannot structurally defend its own conclusions. If an auditor asks the model to isolate the exact constraint that led to a decision, it can only generate another probabilistic paragraph. In high-consequence environments, linguistic fluency is a liability. When billions of dollars or operational safety are on the line, an output that cannot be systematically audited or defended is an output that must be rejected. Enterprise systems require a transition away from probabilistic generation. The work must move toward controlled, deterministic deduction. The energetic paradigm enforces this transition through a specific architectural mechanism, EP function 07, Deductive Reasoning Under Constraint. EP function 07 operates as an integrated system component, bypassing the limitations of superficial prompt engineering or cosmetic text smoothing layers. This mechanism enforces deduction through a rigid geometric matrix. It provides the concrete, auditable operating capability required to make AI safe for enterprise deployment. We evaluate the commercial viability of this function through a strict enterprise triad: demand, execution, and scalability. Market demand appears strictly when a repeated operational failure becomes financially or operationally expensive. Take a standard document review pipeline. A casual consumer chatbot can tolerate a loose error rate, but autonomous financial analysis, governance systems, and M&A contract reviews operate with zero tolerance for logical drift. In an unconstrained model, a minor logical drift cascades. A single hallucinated clause in a merger agreement exerts hidden pressure on the surrounding logic, causing the entire legal structure to fail. This translates directly into liability and risk. An AI output is useless to institutions unless it can survive hostile, line-by-line review by decision-makers, lawyers, and engineers. Institutional buyers are shifting their purchasing criteria. They are seeking structurally reliable logic engines rather than persuasive text generators. The market demand for deductive reasoning under constraint scales proportionately with the depth and risk of the deployment. This leads to execution. A system proves execution when it can repeatedly perform structural deduction under operational pressure. Watch how a raw input is processed. The AI hits the first operational gate, boundaries. This strictly limits the scope of what the model is permitted to consider, instantly discarding irrelevant data. Next, mechanisms. The system defines the exact logical operations the AI is permitted to use to process that remaining data. The third gate applies constraints. This prevents the model from violating pre-established business rules, legal frameworks, or physical realities. At the evidence standards gate, the AI is forced to map every single assertion directly back to verified source data. Finally, failure conditions. The system establishes exactly what parameters trigger an automatic immediate rejection of the output. Applying these 5 parameters changes the initial framing of the task before a single word of generation occurs. Execution is proven because the reasoning path becomes a fully inspectable mechanical process. Standard AI prompting asks if something is plausible. EP applies a rigorous interrogation to an output to ensure it survives in a high-consequence environment. Look at this logic tree. The system must answer a first structural question. Based on the provided premises, what strictly must follow? Second, based on the established constraints, what cannot follow? Third, what claims currently remain unproven by the provided evidence? And fourth, what happens to the final conclusion if a core underlying assumption shifts? Notice the approach to error handling. An error is formally classified and fed back into the system to improve the next execution loop. Forcing the model to explicitly answer these 4 questions ensures that hidden contradictions are exposed before the output ever reaches human review. We move to the final test, scalability. In the EP framework, scalability means preserving the same deductive logic under different task pressures and environments. Deductive logic scales when the mechanism remains recognizable even as the surface content changes. Because the 5-gate filter relies on logic gates rather than specific subject matter, it functions as a repeatable, productizable software module. That module can be embedded directly into document intelligence pipelines to catch legal contradictions. The identical module is inserted into agent orchestration to prevent autonomous agents from taking unverified actions. And it acts as the core logic engine inside enterprise governance systems to maintain regulatory compliance. The structural control mechanism remains the identical, scalable standard across complex legal, financial, and enterprise operational domains. This graph illustrates a pervasive industry fallacy, the assumption that simply scaling up a model's parameter count will organically produce perfect reasoning. The curve hits a hard horizontal asymptote. Without systemic structural constraints, a larger model merely generates a higher volume of plausible, confident errors. EP function 07 shatters this limit by applying rigid architectural discipline to the raw generative power of the model. This defines the core dichotomy of the modern AI landscape. Standard models generate possibilities. EP determines exactly what logically follows. As AI permeates deeper into critical infrastructure, the institutional tolerance for unconstrained generation drops to zero. Deductive reasoning under constraint provides the mandatory operational infrastructure required to convert raw AI scale into reliable, commercial intelligence.